Hi, this is Frank Donald from Gadgetronics. In this video, we are going to see about counters in ATtiny85. This is another video that belongs to the tutorial series that is dedicated for ATtiny85 microcontroller. In this video, we are going to see what is counter and how to configure a counter in ATtiny85 microcontroller. Before heading into the video, I want to drop a quick note. Please visit www.gadgetronics.com. That is our website where we have hosted multiple circuits, tutorials, and projects, and all projects related to Arduino, microcontrollers, and electronics. So I believe that it will be helpful for you. So our motto is to simplify the electronics and present it as easier to understand as much as possible. So that's what we are trying to do. So please do visit gadgetronics.com website and support us. So let's get into the video. To simply put, counter is just an extension of timer that we have in our microcontrollers. So the fundamental difference between timers and counters is how they count, how they perform the count. So for example, timers, what it does is it is going to count the number of clock cycles that is being fed into it, either via external crystal or either via an RC internal oscillator. So it is going to count the number of clock cycles and store it in a register, and as a result we will be able to generate a time delay or signal with precise timings. Okay, so that is what timer does. Whereas a counter, essentially the function of counter is to count events. So when you are say for example, if you are going to build an application where you need to know how many people is entering a particular room, so what counter does is it counts the external events or the incoming signal. Okay, so it can either use to count the events or count the signal pulses, so that we will be able to identify the frequency as well. So that's where the counter and timer basically differs. To get a better understanding, it's always a good idea to get a grasp of how a timer works. So basically, timer and counter share the same underlying principle. So I have made a video about timers, so you can see that here. So it will help you to get clarified of what timer is all about. So but just keep that in mind, counter is just alternative function of timer, where it counts external events or signals, so that we will be able to understand the number of counts that is being interacted by a particular sensor or particular push button, or we can understand how much frequency a particular signal is. So that's how the timer and counters differs. To understand the operation of timers and counters, let's assume that we are feeding our microcontroller with a clock signal. Let's say it's 16.5 MHz, and we are feeding our microcontroller to synchronize the operation. And timer is going to use this clock signal as a source to perform the tracking of time. So that's what the function of timers. Whereas a counter, it takes source from input of sensors or push buttons or any other signal sources. So the agenda of counters is to count the number of events or to count the number of high to low signals, so that we can determine the frequency. Whereas in hardware part, there will be a specific pin assigned to take signal from external sources. So in my ATtiny85, PB2 is going to be our signal source for counter. So PB2, this does have the special function called as T0. So this pin will be responsible for taking the input to increment the counter in our microcontroller. Here you can see the basic setup of a counter operation. So we have connected a push button along with a pull-up resistor to PB2 pin. So whenever this button gets pressed, and we are going to program this to light up these two LEDs after reaching a certain number of counts, that is the certain number of times the button has been pressed. So that is what this is going to be. So whenever this button gets pressed, so it's going to trigger the count to PB2, and the timer, the counter value will be stored in TC and TO register. This is the same register that the timer uses to count the number of clock pulses that has passed to generate time delays. So in essence, we can say that the timer and counter cannot work at the same time. Either you have to configure the timer to use as a timer, or it has to be used as a counter. So it cannot happen on the same time. So this is a basic setup that we are going to look at for counter. Let's take a look at how to configure counters in ATtiny85. So the TCC ROA register is responsible for setting the timers, using the timer, and so we are going to set it up as normal mode, and this is what we need as well. And here OCA is OCA and OC0P or feature that is associated with compare match, and we are not going to need it, so we are setting these two bits as 0 and 0. So we have all the bits. It's going to be 0 0 0 to select these modes, and this is going to be 0 0 as well. On the next register is TCC ROB. So for this register is the key in setting the timer to operate in counter mode. So when we have all set of these combinations which we need to use when we are going to use timer to count to generate time delays. So we have the pre-scalars here, and the last two options is going to be our thing for choosing counters. So if we set CS02, 01 and 00 as 110, we are going to select the external clock source on T0 pin. If you remember from what we have explained so far, so the T0 pin is going to take the counter input, and so here the clock on falling edge will be counter. This will trigger the increment of counter value in TC and TO, which is the register which stores the number of counts that has surpassed. So when we set it up at 111, it is going to be on rising edge. So either we can set it up as falling edge or rising edge. So we are going to choose 110 here, since we have used pull-up resistor in our circuit setup, which we have shown already. So we are going to use a 110. So by doing this, we will set our timer to operate as a counter, and it will be ready to count external events or signal frequencies such as. Now that we have configured the ATtiny85 to operate as counter, with every button press of this push button will trigger the count in TC and TO register. It goes from 0 to a maximum of 255. So it's our programmer's job to check the value in this register for any predetermined value. For example, if I intend to light up this D1 LED when the count hits 10, so I have to check the register for TC and TO for whether it has reached 10 counts, and have to light up the LED. And if I need to light up this D2 when the count hits 20, then I need to keep checking the TC and TO register to see if the count has reached 20. So that's how the counter works, and that's how we are going to retrieve the count, that is retrieve the count or frequency or whatever that is being encountered by the counter pin T0, that is PB2. So if we are going to exceed, the count is going to exceed beyond 255, then there are two methods that we can use to detect, and then we can use the counter to further count the events after it overflows. Let's see the first method. This TIFR, this is a flag register which usually indicates the status of timer. So here we have overflow bit. This is the one which we are particularly interested in. This flag T0V, TOV0 will be set to 1 whenever the counter reaches from 0, starts from 0, and when it reaches 255, this flag will be set to 1, so that we have to read this flag bit and understand that the counter has reached its maximum value. When we select the normal operation and when using a timer, so it automatically, the TCNTO register which stores this 0 to 255 will automatically roll over and will automatically start from 0. So we don't have to worry about resetting the timer register to start counting again. It will automatically overflow and counts back. So what we have to do is, whenever this flag is being set, we have to understand that the count has reached 255, and when we are reading the TC and TO register after one single overflow occurs, so it means, say for example, the current state of TC and TO register, TCNT0 register says has about 5, the count is 5, which is the value which is being read in TCNTO register, which means now the total counter value is 256 in the sense it goes from 0 to 255. So the maximum value is 256 here plus 5. So we can deduce that our total counter value is 261. So this is how we are going to perform the counts. When the second time the counter overflows, we are going to understand that the counter has reached 512. So just 256 into 2 is equals 512. So that is how the overall counter reading and interpretation occurs. The next method is using interrupts. So this S register activates the overall this register. The I bit in the S register activates the overall interrupt. So we have to enable it, to write one to it to enable the overall interrupts, and to activate the timer or counter interrupt specifically, we have to go to the TIMSK register and have to write one to it. So when the interrupt is being activated, we no longer need to check the flag register in TIFR register, which we have seen previously. So we have we have to monitor the T0VO flag continuously and understand whether the flag has been overflowing. But when we enable the interrupt, so the program will automatically transfer the control to our interrupt subroutine, where we can increment the number of overflow that is being occurred. For example, if one overflow has occurred, just like we have calculated previously, we can understand that it is equal to 256. When the interrupt occurs for the second time, it is going to be another 256. So we can understand that the counter has overflowed twice, and the count is now 256. And additionally, we can also read the TC and TO register, which actually holds the value of counter, and we can add the counter to these values, and finally deduce the number of counts that is being encountered by the counter register. In addition to this video, we have also documented this counter tutorial in the form of an article in our website. So I have given the link in description where you can read about this counter configuration and the working of it in detail. So we have almost explained every aspect of it. So let's take a look at the code counterpart. This is going to be a simple one where we don't expect our counter to exceed 255. So for configuration, TCCRO register is being written as 0 and TCCROB register is being written as 0 as well. So, and the TCCROB, we are configuring CSO02 and CSO01 to take inputs from T0 pin and to increment the counter when it encounters falling edge, right? So, and TC-NTO register is being written as 0. This is what we when means we are initializing the register to count from 0. So what happens is we are periodically checking the TC-NTO register for the values, and when the value exceeds 10 and stays within 30, we are going to light up the LED which is connected to PB1. Remember the circuit diagram which we have seen earlier. And also in port, when the count in TC-NTO register exceeds 30, we are going to light up the LED connected to PB0 pin. So this is a simple counter example where we don't have we are not expecting the counter to exceed more than 255. When the counter exceeds more than 255, we need to handle that using either by monitoring the flag register as we have discussed earlier, or we have to use the interrupt method. So here we are going to see the interrupt method used in this code. We have a configure counter just like the previous one, and we have enabled the global interrupt as well as the timer overflow interrupt. So whenever the the counter value overflows in TC-NTO register, the program will transfer the control to this ISR routine where the I value, the variable I, will be incremented. So we are actually monitoring the TC-NTO register, reading the TC-NTO register over and over again, and the actual value counts by the number of times the interrupt has occurred into 256. So whenever, if the interrupt has occurred only once, so it will be multiplied by 256, which means the number of TC-NTO, for example, the TC-NTO has a value of about 5. So just like I have explained in the example, so our actual count will be 256 plus 5 equal to 261. So that is how it works. So when the interrupt occurs for the next time, it will be 512. I will be 2, and 256 into 2 equal to 512, and that therefore that along with it the TC-NTO value will be added as well. So that's how we get the actual count, and that's how it will be monitored as well. So yeah, that's all with the counter, and here you can try out this simple exercise which we have added here. It will be of useful to you. Hope this video was informative to you. If it is, please drop a like, and if you have any comments or thoughts that you need to share with us, please use the comment section below, and do subscribe to our channel for more of these videos in the future. And we have created a special ATtiny85 lesson plan which you can use to learn and program ATtiny85 in about 10 days, and I have added the link in the description. Also, there are additional resources which will help you to learn ATtiny85 along with this video. So I have added the links in the description as well. Do stay tuned, and there are more upcoming videos in ATtiny85 and other electronics tutorials and series as well. So do subscribe, and thanks for watching.